So, with trigonometry, what identities have you come across in first year AS Maths?
One takeaway cos squared x equals sine squared x.
Okay, yeah, one takeaway sine squared x equals cos squared x. Absolutely.
And then the cos x over sine x equals tan x.
Other way around.
Oh, sine x over cos x equals
Yes.
tan x.
Sine x over cos x is identical to tan x. So this is useful. And yeah, 1 minus cos squared x is sine squared x. Absolutely. There's just the other variation that we have is sine squared x plus cos squared x is identical to 1. Okay. Well, firstly, there are 3 new trigonometric ratios. They're not really new, they're just basically applications of the ones that we already know. And the first one is called sec x, which is the same thing as 1 over cos x. The next one is called cosec x, which is the same thing as 1 over sine x. And then we've got cot x, which is the same thing as 1 over tan x. So you may want to jot these down because we're going to use them. Okay, what I want you to do now is using that identity, the sine squared x plus cos squared x is identical to 1. I want you to divide every term by cos squared x. Divide every term by cos squared x and see if you can simplify all 3 terms. So I'll give you maybe a couple of minutes just to have a go.
The sec, cosec, and cot.
No, as in, so you're going to take this identity here and divide every term by cos squared x.
Oh, okay.
What do you mean by every term?
So each term, sine squared x, cos squared
Right.
x, and 1, and divide them all by cos squared x.
All right, sounds good.
Have you got something?
Yeah.
Yeah, okay. Kieran, have you got something? Yay, yes, no?
I think I might have got one.
You think you might have got something? Okay, well, we'll have a look. So, give me one moment. Right, so we have, let's write this one in black. Sine squared x divided by cos squared x plus cos squared x divided by cos squared x is identical to 1 divided by cos squared x. That should be our first step. Is that okay?
Yeah.
Cool. Kieran, how's that for you?
Yeah, that's good so far.
Okay. And then question, how do we simplify that?
And cancel out the cos squared x and the cos squared x.
And that should give us
Sine squared x over cos squared x equals 1 over cos squared x.
when you say, okay, we don't cancel like that, but the cos squared x over cos squared x cancels to, it becomes 1 because anything divided by itself is 1.
Oh, yeah.
What about the sine squared x over cos squared x?
Could that equal tan squared x? Or?
Indeed. Indeed. Because we know sine over cos is tan, so therefore sine squared x over cos squared x is going to be tan squared x. And using our new definitions, what does the 1 over cos squared x simplify to?
Sec
Squared x.
Yeah, sec squared x. So let's write that down. So tan squared x plus 1 is equal to sec squared x. So this here is actually a new identity as well, which you've gotten just from taking the sine squared x plus cos squared x. Okay, so that's this one. Now, by starting with this identity again, can we divide everything through by sine squared x this time and see what we get?
Which identity?
The sine squared x plus cos squared x is identical to 1. Can we divide each term now by sine squared x and see what we get? Okay, and let me know when you've got an answer.
I have an answer.
Cool. Kieran, have you got an answer as well?
Oh no, I'm a bit unsure.
Okay, well, let's go for it anyway. So tell me what you have, Aisha.
I got 1 plus cos squared x over sine squared x equals cosec squared x.
Okay, that sounds good. We can go further, but that sounds good so far. So I'm going to start off with the same process, sine squared x over sine squared x this time, plus cos squared x over sine squared x is identical to 1 over sine squared x. So sine squared x over sine squared x is the same thing as 1. And you also mentioned that 1 over sine squared x is the same thing as cosec squared x, which is fine. What about cos squared x over sine squared x?
Would it be cot squared x?
It would be cot squared x. Why is that?
Because it's 1 over tan x, and tan x is equal to sine x over cos x.
That's it. It's basically just the reciprocal of what tan x is. Cos over sine is like the upside down version, if you like, of sine over cos. So it's the upside down version of tan, which is cot. And this is our other identity that, again, you probably want to make a note of, because we're going to use these identities in questions to come. Okay, so let me know when you've noted that.
Yeah, I've done it.
Cool.
So
Lovely. Okay. Now what I'm going to do is I'm just going to show some questions, but we won't go through all of them at once. We'll go through just some of them. We've got to simplify these expressions. So if we go on slide 4, we're just going to be looking at some expressions that we'll be simplifying. And remember to make note of the new identities that we've just been using, because you'll need these. So the first one just makes use of the identity that one of the identities we've just learned. Any takers for this one?
Oh, no.
No?
Oh, would you just use the tan squared x plus 1 equals sec squared x?
Yep. And in this case, we're going to put sec squared of what?
Sec squared of a half
Of a half theta.
theta.
Yes. So using the fact that we know 1 plus tan squared, or tan squared x plus 1 is equal to a half theta, we know that this is simply going to simplify to, sorry, using the fact that tan squared x plus 1 is sec squared x, we know that this is going to simplify to sec squared of a half theta. Okay. With the second one, just to help you out, you're going to need to expand the bracket. So I'll give you both a chance to do that. So again, I'm just walking through with you just to get you to get familiar with the identities. You're going to need to expand the bracket.
Is it sec squared x plus sec squared theta minus 1?
Say that one more time. Sec squared x.
Sec squared theta minus 1?
Yes, so it simplifies to sec squared theta minus 1. It's a difference of two squares.
Pardon?
It's a difference of two squares, as in that's the expansion.
Yeah.
And this can be simplified a little bit more as well, using an identity that we know, probably in reverse, or rearranging one of the identities we know.
Oh, would it equal tan squared x?
Yes, tan squared theta.
Oh, tan squared theta.
Because the identity that we were given, I'm going to write it in a different color. We had that tan squared x plus 1 is identical to sec squared x. So if I take away 1 from both sides, I'm left with tan squared x is identical to sec squared x minus 1. So similarly, we can take this blue one and say that this is just simply equal to tan squared theta. So the whole point of this is just to get you familiar with the identities. So I am going to be like walking through these things with you. Okay. What about the next one? What kind of ideas could we use here? There are quite a few ways to go about this one, but what ideas do you have?
Could you first change the cosec squared x into one? No,
Yeah, go on.
one over sine squared x.
You could do that. You could do that. To be fair, that could work as well.
Or one plus. Oh, sorry.
Yeah, go on, go on. Go on. I think you
Oh,
said it.
me.
Yeah.
1 plus cot squared x.
Yeah, that probably is going to help us more because we're using the identity. So we know that 1 plus, I'm just looking for the identity. We know that 1 plus cot squared x is identical to cosec squared x. So I can rewrite this as tan squared theta multiplied by 1 plus cot squared theta. That's replacing the cosec squared theta. And you've got the minus 1. Okay. Now, how does that help us? Where can we go from here?
Take the 1 away.
What's that?
Take the 1 away.
Yep. So what would that become?
Cot squared theta.
Yep. So that becomes tan squared theta multiplied by cot squared theta. And we can actually simplify this a little bit more as well.
Could you change cot squared theta to 1 over 1 over tan squared theta?
Absolutely. 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 Yes. You are both very, very good. You've got this. Tan squared theta multiplied by 1 over tan squared theta. Because that's what cot squared theta is. And then that's like asking to be simplified just a little bit more.
Would it just be 1?
Yeah, because anything multiplied by its reciprocal, by definition of what a reciprocal is 1. So how is that so far?
Easy.
Easy.
Pretty good.
Pretty good. Yeah, I think at this stage, it's just, again, it's just about getting you used to these new definitions and the new identities that you've learned as well. That's what this is all about. Okay. On slide 5, there are 3 more things that we're trying to simplify. So again, any ideas, just shout them out. We'll work through them together.
Change sec squared theta to tan squared x plus 1.
Yep, tan squared theta plus 1 in this
Tan
case.
squared theta.
So this becomes tan squared theta plus 1. Then we've also got the minus 1 because of the minus 1 that's there, multiplied by cot theta. Good stuff.
Would you change cot theta to a 1 over tan theta?
That works, yep. So I've got tan squared theta plus 1 minus the 1 multiplied by 1 over tan theta. Indeed, that helps a lot actually.
Did the ones cancel out inside the bracket?
Yep, the ones in the brackets cancel out. So I purposely didn't cancel it because I wanted you guys to say. So tan squared theta, and then we don't really need the bracket anymore, multiplied by 1 over tan theta.
It just equal tan theta.
Yep, that simplifies to tan theta. Because it's essentially tan squared theta divided by tan theta. Nice. Okay. Next one, I guess.
Would you first the indices first?
Would you do what, sorry?
Oh, you expand the bracket.
Yeah, you could expand the bracket. I'm just looking to see if there's anything else that we could do, because
Oh.
expanding the bracket would take us into fourth powers and I'm seeing something else based on the identities that are there. They might be a bit easier than expanding first.
Oh, just change cosec squared x for 1 plus cot squared x, and then take away cot squared x from cot squared x.
Yeah, so this becomes, so we know cosec squared theta is 1 plus cot squared theta. So 1 plus cot squared theta minus cot squared theta all squared. And then where can we go from here?
Take cot squared away.
Yep, which leaves us with
1 squared.
Yep, just 1 squared, which is
1.
just 1. So you could have gone by the route of expanding, but that could have taken you into a whole big mess. So expanding sometimes is useful. It's the only thing you can do. But one tip that I would say is when you're at A level, try to prolong expanding for as long as possible. Because usually when you expand stuff, there's a lot more work you've got to do. Now, of course, you can expand if it's the only thing you can do. But if there are other things that you could do beforehand, try and do that first. But yep.
Yeah.
We got it. And the last example, or the third one on this page anyway.
Would you first change sec squared x to tan squared? Oh no, sec squared theta to tan squared theta minus plus 1.
So this one would become 2 minus tan squared theta plus, and then the sec squared, yes, we know is tan squared theta plus 1. Then what can we do?
Tan squared theta take away tan squared theta is 0. And then 2 plus 1 is 3, so
Yep.
it's 3.
Yep. So it's just 3. That's what all of this is. All of this is just testing our application. Right, let's try the other questions. So again, the whole point of this is just for us to get used to this idea of sec, cosec, cot, and the identities, which I think you're doing really well with so far, both of you. So that's good. And of course, if anything doesn't make sense, for either of you, please just say. Okay, so slide 6.
Mm,
What ideas maybe come?
would you cancel out the tan and the tan squared theta?
Unfortunately, you can't do that because at the bottom, the tan squared theta has the +1 with it as well.
Mm.
So we can't just pick and choose in that sense. You'd have to divide everything by tan.
Oh, you changed tan squared theta +1 to sec squared theta.
Indeed, yes. So we see that at the bottom, we've got 1 plus tan squared theta, but that's the same as sec squared theta. So this becomes tan theta sec theta over sec squared theta. And then from here,
You cancel out the sec squared theta and the sec theta.
and what would you be left with?
Tan over sec theta.
Yep, tan theta over sec theta. That's pretty much it. I mean, there are other ways in which you can express this, but this is pretty much. Oh, actually, wait, no, I lied. No, you can actually simplify this a bit more.
Change sec theta to 1 over cos theta, and then you do the flipping thing.
Okay, so this becomes tan theta divided by 1 over cos theta, and then do the flipping thing. So tell me what you mean.
So it becomes tan theta times by cos theta.
Indeed, yes. Because you're dividing by a fraction, it's the same as multiplying by the reciprocal of that fraction. So that's tan theta times cos theta over 1, which is just the same thing as tan theta times cos theta. And then from here,
Oh, you. Oh no.
go on.
Oh, I don't know.
What were you going to say?
I was going to say the sine theta over cos theta equals tan theta.
Let's do it. Sine theta over cos theta, replacing tan theta with that. And it's still multiplied by cos theta.
Oh, and then you cancel the cos theta times by cos theta will cancel it out.
Yeah, the cos theta and the 1 over cos theta is cancelled. So you're left with just sine theta. So all of that, and we simplified with sine theta. Nice. Kieran, how's that for you?
Pretty good, thanks.
Cool. Any questions at all?
Like this isn't for G. This is for like I, because I was practicing I before.
Okay.
But say like something on top. So when like cosec,
Mm-hmm.
if I was to change that to like 1 plus cot.
You can't change cosec to 1 plus cot because that's not an identity. The identity is cosec squared,
Oh yeah.
1 plus cot squared.
Oh.
But okay, taking that, what can you change though from that question?
The 1 plus cot squared to
Yeah.
cosec squared.
Yeah. So that becomes cosec theta cot theta. That's divided by cosec squared theta. And then where can we go from there?
Are you sure?
Would you change the cosec squared theta to 1 plus cot squared? Oh no, never mind. Oh, would you just cancel out the cosec and the cosec squared theta?
Yeah, one of the cosecs from the top and bottom would cancel. So cot theta over cosec theta. So you mentioned the whole, would you change cosec squared back to 1 plus cot squared, but then maybe you realized, I think, that that's what we just did.
Yeah.
So yeah. So dividing the top and bottom by cosec, the top becomes just cot theta, and the bottom, well, cosec squared divided by cosec is just cosec. Okay. Then from here, what can we do?
I don't know.
What's that?
1 over. No. Oh wait. Would you do 1 over? I'm not sure. Or would you just change the cosec theta back to 1 plus cot squared theta?
Well, now
Oh
we
no.
can do it
Oh
because
no. It's
squared.
cosec theta would be 1 over sine x.
Mm.
Oh, and then you change the cot to 1 over tan x.
Okay, so let's write this one first. So cot theta divided by, you said change cosec to 1 over sine. So over 1 over sine. And that's the same thing as?
Cot theta times by sine theta.
For the same reason as what we had there. So cot theta sine theta. And then?
And then cot theta is equal to 1 over tan theta, which is also equal to cos theta over sine theta.
Lovely. So cot theta is 1 over tan, which is cos theta over sine theta. So that becomes cos theta over sine theta multiplied by sine theta.
So the answer is just cos theta.
That's it, just cos theta. That's the one. Lovely stuff. And then we'll finish the last one, I guess. So I'll go through this one really quickly, just I realized the time. So 1 minus sine squared theta is cos squared theta. Using identities from before, the sine squared theta plus cos squared theta is 1. And 1 plus tan squared theta is sec squared theta. And then that's just 1. Because cos squared theta multiplied by sec squared is 1 over cos squared. So that's just 1. So
Thank you.
that's all right. Yeah, we've got the final questions, which are here. I'd give them a go. I'd recommend giving them a go. I can put some more questions just to help us get used to these things. So I'm going to copy those now. They're quite extensive. They do get quite challenging. But the whole point, again, is just to practice getting used to new values and new identities. So there we go. And I'll provide answers for these as well on the next slide. But yeah, well done to you both. Cool. Okay, that being said then, take care. I will see you both on Tuesday, where hopefully we can carry on a little bit more with this.
Sounds good. Thank you.
Lovely. You're welcome.
Thank you.
You're very welcome. Okay, take care. And
Cheers.
now.
Bye.
Bye-bye.